So I needed to add one little bit to what we talked about in class today, and that is, what do we do if we don't have a unit circle? So we're still looking at circles, but what happens if the radius isn't 1? Well, we still have the same kind of equation for a circle, x squared plus y squared equals r squared, and that's going to help us out. And then we just have to have some different values for our sine, cosine, tangent. So what happens is sine theta will now be y over r, so we have to use this different radius. Cosine will be x over r. Tangent, sine over cosine, well, that ends up being where the r's go away, so tangent doesn't change. Tangent is still y over x. Cosecant, you flip the sign, so I have r over y. Secant, I'm going to flip the cosine, I have r over x. And then cotangent is going to flip and be x over y. So tangent and cotangent will feel the same. Sine, cosine, cosecant, secant, those will feel a little bit different. You'll feel that value of r come in. To show you that, I'll just do a quick example with finding the values of the trig functions at the point 512. So what I picture is this, I have some kind of circle, right? We'll pretend like I'm drawing it well. And say somewhere on this terrible circle that I drew, there is a point that's going to be 512, right? So we're just making it so we can kind of visualize what's going on. I need to know what the radius is, right? What do I know? I know the x, I know the y, but I need to connect them with the equation 5 squared plus 12 squared equals r squared. You can grab your calculator. 5 squared is 25, 12 squared is 144, together that's 169. That's r squared, that says r is equal to 13. So just a quick little like Pythagorean theorem kind of thing. All right, now that we know our radius, now we can figure in all of our values of theta. So I start with sine of theta. Well, remember that sine is using the y value, which is 12, but now you have to divide by your radius, which is 13. Cosine, again, we're going back to theta, which is x, so we're looking for our 5 over 13. Tangent is sine over cosine, so that's 12 over 5. Cosecant, you're going to flip sine, that's 13 over 12. Secant, you're going to flip the cosine, that's 13 over 5. And then cotangent, I'm going to flip over tangent, that's 5 over 12. In case it helps, I thought I would point out this connection between using a unit circle and maybe some right triangular trigonometry that some of you may have seen in the past. So just real quick to show that if we had this, when we look at our triangle, the x value 5 is across the bottom, the y value 12 is across the top, like going up, and the 13 would be the hypotenuse. So sometimes what you learned of sine might have been the opposite over the hypotenuse, but you can see here sine theta, if you look at it the opposite, which was across from the angle over the hypotenuse, let's get rid of that, you can see it was 12 over 13, right? So cosine, same kind of thing. Cosine of theta, if you ever learned it as adjacent over the hypotenuse, you can see it. Here's the angle theta. Adjacent is the 5. The hypotenuse was 13. So you have 5 over 13. And then the tangent of theta, maybe you learned it as opposite over adjacent. So opposite 12, adjacent 5. And you still have the same value. So if that helps you, great. If it doesn't help you, ignore it. But sometimes I know people have seen 2 different ways to do something. I want you to see they all mean the same thing. It's just our particular book uses the unit circle. So we did the x squared plus y squared is r squared, but maybe you know the triangle too. We will work more on this on next class. Don't let it sweat you too much. We'll keep making it bigger.